for me, thinking about these problems, the hardest thing to do is to figure out which thing this problem needs. So analyzing just how to get x so that it says x equals, which method do you use? Because there's several with this kind of problem. So in order to solve for x, it can't be in the exponent position. It can't be up here. We have to move it down. So we're going to have to change it into a logarithm to do that. We can use the logarithm that's given right now. We can rewrite it as a logarithm or take the log of both sides, whichever way you want to do. If we do that, we'll have log base 11. So here's what I mean by that. If I rewrote this and thought about it as a logarithm with base 11, because that's the base, and it's equal to the exponent because logarithms are exponents, then 10 goes here. Okay? The other way to think about it that's going to give me the same result is for me to take the log base 11 of this side and the log base 11 of this side. And the reason it's the same is because if I have base 11 and base 11, these guys cancel, and 3 to the x is down on the ground. And I still have log base 11 of 10. Now, how's that helpful? The x is still in the denominator. That's kind of gross. But what it does is it allows me to just do math that I can put in my calculator. So if I make this a fraction and this a fraction, I can cross multiply, and that would give me x. So I'm going to multiply. I'm going to write it big. 3 over x. Then I'm going to cross multiply x times this side, x log base 11 of 10 equals 3 times 1, or 3. I'm so close to having x by itself, but it's multiplied by something. So now I need to move this to the bottom and say log base 11 of 10. So if I divide both sides by that, then those cancel. I have x equals, and this you can put in your calculator. So for most of us, putting in the calculator, we're going to write that log with the base 11, but I'll show you how to do it with a change of base as well. So if we said 3 divided by a fraction, I can make this log of 10 over log of 11. So that gives me 3.124. Did they want 4 decimals? Nope. Or I can type it in just like this. So if my calculator will let me, I can say fraction 3, and then I can do the math button and find this button with log base. And then I can put in 11 and 10. And it gives me the same answer. So either way. So looking at the problems and deciding what to do, that's the hardest part. But in all of these, if x is an exponent, then we have to use some sort of log to get it down, if that makes sense. So I showed you 2 different ways to get it down, but somehow we have to get it out of the exponents so that we can solve for it. Next on my list was 5. Okay, 5. 5 also has x in the exponent, so we have to bring it down somehow, right? So I need to bring it down using some sort of logarithm. What logarithm makes sense for this problem because I have a base of e? What's the one that undoes it? What's the one that has a base of e itself? So all of these logs, if they have a number, all of them that have a number go with log, the word log. The one that doesn't have anything here is a 10, but there's one other weird one that goes with E. No, that's 2.7. That's what E is. But there, instead of writing log, we write the other one. What is it? It's the other button. It's LN. It's the other one we have in our calculator. Thank you. So what we're going to do is we're going to take the natural log of this side and the natural log of this side. Why do we do that? I'm going to write it big. Natural log of E 15 minus 3x equals natural log of 28. Like I just rewrote what I just did. I took the natural log of both sides. I'm using a log. It's just this special one that goes with E so that I can bring this down. And that's what's weird about this one is this is an exponent. There's two ways I can do that. I'm going to do it the easy way. This is a base of E. That's the whole reason we use natural log. Because then we can go, these are opposites. They undo each other and they cancel out. And now we have 15 minus 3x equals the natural log of 28. We need our calculator for that, but that's fine. We're allowed to use our calculator for this problem. I'm going to solve for 3 the way I would in any algebra problem. I'm going to move the 15 over. So we have negative 3x equals natural log of 28 minus 15. I can't combine them, okay, because natural log is its own function and 15 is a number. I have to leave them separate. X is really close to being by itself. What do we do to undo the negative 3? Opposite of multiplication? Division, right? I'm trying to undo the negative 3. So if I divide by negative 3, it cancels and makes 1. And now I have this that I can put in my calculator. Just like that. So the hardest part is the first step. We'll look at that again. Let me find this answer and we'll put that in. So I'm going to do a fraction again, alpha x, because that's easy. And then I'm going to say natural log of 28, parentheses, minus 15 equals, oops, that was stupid. I already had a place to put it. I just didn't put it there. Negative 3, 3.89. So if x is the exponent, we have to get it down by using the inverse operation to exponents. To undo an exponent, we have to use a logarithm. But this time we had to use the natural log. Or it was easier if you used the natural log. Or you can rewrite it as a logarithm, but you still need natural log that way. We said before, if you use natural log of E of 28 equals the exponent. And that's the same equation right here, just written backwards. So we learned how to write exponentials and logarithms back and forth. We had that as a section where we learned how to do that. But either way works. If it didn't, that wouldn't be good math. So that is 5. So let's do 7. 7 says 10 to the 2x plus 5 equals E. So where's x? Is x in a place I can solve for it right now? It's up in the exponent place, right? If it's up here, we have to bring it down. We do that with logarithms. So we're going to take a logarithm. What base makes sense? What base do you see in the problem? 10. So we're going to use 10. So I'm going to move this 7 out of the way. It's in my way. I'm going to say log base 10 and then log base 10. I'm going to log base 10 both sides, just like I would add 5 to both sides or something similar. And the reason we do that is because these are opposites. They undo each other, and 2x plus 5 comes down out of the sky, and it equals log base 10 of E. There are still two things happening to x. we need to move this 5 and divide by 2. So we're going to say minus 5. So 2x equals log base 10 of e minus 5 divided by 2. X equals, and we put all that in the calculator, just like it says. So I'm going to say, that's really small. I'll use this calculator. I think I have it up. So we can say fraction. I have log base 10, and this calculator button is the 10. So I don't have to even type in a base. But I do have to put in e. It lives here. E to the 1, because that's all I have in my problem. It just says e. That's e to the 1. And then minus 5 all over 2. Negative 2.28. This is, I just erased it. It was 7, right? Yeah. This is number 7. And the final answer is x equals negative 2.28. So to get it out of the sky, you have to use logarithms. That's why we learned the inverse function. So 3, 5, 7. We've got 11 to do. 11. 2 to the 6 minus x equals 10. Oops, you can't see anything. Sorry. 2 to the 6 minus x equals 10. I have to get it up out of the sky. So how do I do that? What's a smart log? Okay, so parentheses here, like this. What else? Okay, I can't do that. I have to get it out of the sky using logarithms. So I can either take log of both sides, or we can say log and write it out. Of these 3 things, 2, exponent, and 10, which of those 3 things is the base? 2. So log base 2. Which one is the exponent? So it goes here. Oopsies. So since logarithms are exponents, we say the exponent on the other side, and then what's left is the 10. Log base 2 of 10 equals the exponent 6 minus x. So we're using the same base in the logarithm, and then we're going to solve for x. We're going to move the 6 to this side. We have log base 2 of 10 minus 6 equals negative x. If we multiply everything by negative 1, we'll have negative log base 2 of 10 plus 6. And then we put that in our calculator. Oh, big calculator. So big calculator says this negative, and then log base 2. So math log base 2 of 10 plus 6, 2.68. Oh, hello, paper. So we type it in. If we didn't have that button, we would have written this, negative log of 10 over log of 2. 10 goes on top, 2 goes on the bottom. This is how you do it with change of base. And that's because we have a log button. It just says log. Okay, so 11. 15 is next. How we doing? Is this making sense as we go through it?
It's like certain things that make sense, and then some kind of get lost.
So we've got to memorize the idea that that you can go. These are 2 different ways that say the same thing. So this could be Jack, and this could be Mr. Vuich. There are two different ways to call you by your name, but they both mean you. So we need to get the idea that the base goes here in the bottom, and that logarithms are exponents, and that's why when we do this notation with logarithms, we take the exponent and write it here. It's like on the ground. That's sort of how I think of it. It's not up in the sky anymore, something that I can't figure out. I've brought it down to the ground. It's manageable now. So that's what we're trying to do, and you've got to memorize kind of those rules for this to make sense that way. So 15 is next. 15 has two exponents. So that's interesting. We've got e to the x minus 4 equals 4 to the 2x over 3. So lots of things going on there. I'm not going to be able to do it exactly the same way I just did. Instead, because I have two different bases here. So instead, I need to pick one of them, and I need to do that on both sides. So, Jack, do you want to pick E as the base that we want to start with, or 4? Because it doesn't matter. We just have to pick one. E. So if we're going to choose E, if we're trying to undo E as an exponent, or an exponential, we're going to use the natural log. So we're going to take the natural log of this side, the natural log of this side. I squeezed it in there. We use the natural log because it hasn't understood E as a base. And what's cool about that is because we used one that makes sense, these cancel each other out, but only on that one side. They don't cancel over here because E and 4 are not the same. But on this side, they cancel out, and now we have x minus 4 is not an exponent anymore. It's just on the ground. So we have x minus 4. Now on this side, it's more complicated. Let me write it bigger so we can see what's going on. There's one more rule for logarithms that we haven't used today. Maybe we haven't used several rules, but here's one. If we have a power, we can move it to the front. That's a rule that we learned that deals with exponents, and since logarithms are exponents, we can use this rule. And that lets us do x minus 4 equals 2x over 3 times the natural log of 4. Or you can keep the little e there. So, now what to do? In Algebra 2, we learned a rule that said if you're solving for x and there's more than one x, then you have to factor. So that was a rule we learned in Algebra 2. We're going to have to apply it here because this term has x in it and this term has x in it. So I can't say x equals something with x in it. We got to factor it out. So what I'm going to do is I'm going to swap this and the negative 4. I'm going to swap sides so that on the left I have everything with x in it. And then on the right I have things without x in it. So this was positive on the right. I moved it over. Now it's negative. This was negative. I moved it over and now it's positive. So I'm telling you what the rule is. I'm telling you what my goal is. I'm trying to factor x out so that I only have one of them. So if we take it out, this is what it's going to look like. It's going to be x. And then I'm taking it out of here and here. In the first term, if we take out x, we need a placeholder. We take it out of the second one, we take it out right here, we're left with 2/3 the natural log of 4. So this one's more complicated to see this. X is so close to being by itself, what's happening? Is something added to it, divided, multiplied? What's happening right now with the x? The parentheses means that we've got something multiplied by it, right? So in order to undo multiplication, we're going to divide by this whole thing. 1 minus 2/3. It looks really gross, but the thing is, is I don't care because the calculator is going to do all the hard stuff, okay? I just have to figure out the math. So I'm going to divide this side by the whole thing and then this side by the whole thing. And so this cancels and x is left. And I have to put this in my calculator. So I'm going to put 4 divided by 1 minus 2/3 natural log of 4 in my calculator. So I'm going to do fraction because that's easier. 4 divided by 1 minus, I'm going to say another fraction, 2/3 natural log of 4. And that just has its own button, natural log of 4. And I get 52. 15. Oops, can't see it. And I rounded up, so I've got this. So what did we do? Let's compare 11 and 15. All right, 11 had only one exponent and only one x. 15 has 2 exponentials. So we ended up with a much more interesting problem because of that. It also has an x here and an x here, which meant we had to factor it. So a lot of work went into that one, solving it. $11, $15, $24. $24. 10 to the 6x equals 3, 3x plus 4. So this problem is like 15. I have 2 exponentials. Javier, do you want to undo the 10 as a base or the 3? It doesn't matter, we just pick one. 10? So if we're undoing the 10, we can do the easy thing, which is just log of both sides, because it's an understood 10 there. If you're not sure, write the 10 in. It's perfectly fine to put the 10 in there. So we just choose one. We could have done the 3, but the 10 is easier because that's a button on my calculator. So good choice. This is a log and an exponential with the same base, so 6x is now out of the exponent position. And then I have this as a power. I'm going to write it in the front, times log base 10 of 3. So I rewrote this in a way that I could follow it. Exponents get multiplied. That's the power rule. And then now, same problem. I've got 2 x's, right? So I've got to get it on the other side. I can't get it on the other side with the 4 there. I need to fix it. So what I'm going to do is distribute this log on both. So I'm going to write it big so we can tell. If I say 3x times log of 3, are y'all okay if I drop the 10? It's an understood 10. It's a lot of writing. Okay. So 3x times log of 3 plus 4 log of 3 equals 6x. And now with the 3 different terms, I can tell that I need to move these 2 to the same side. And I need to factor out the x like we did the last problem. So 6x minus this guy, 3x log of 3 equals 4 log of 3. Both of them have an x. We're going to factor it out. That leaves 6. We're going to factor this one out. We're left with 3 log 3. It's what? I know, we're treating this longer thing like a number. And it is a number. You could totally, up here at the top, you could make a decimal for that and do it at the top. But it's easier to keep up with if we just call it log 3. And it is a matter of like accepting this as a number because it looks so weird. But if you think to yourself, what rules am I looking at? So right now, since it's factored out, the rule is x is multiplied by something, even though it's big, right? We don't care. The rule is if x is multiplied by something, to undo it, we divide. And so those cancel out, x is left by itself, and we put this in our calculator. And it's the regular log button. It's the regular, this button right here, this button right here that says log, it's just that button. So I'm going to do a fraction again, green x, 4 log of 3, parentheses, 6 minus 3 log 3. 3 log of 3, parentheses, enter, 0.42 for 24. So I'm going to post these solutions written on paper. You might want to try another one or two and see if you can follow. Obviously, the video is going to be posted for our friends that aren't here, but I'll scan these and upload them. Hopefully, they're not so messy that we can't follow. And then you're going to have some other ones to do anyway, because what we're doing for tomorrow for our distance learning day is these problems in the chapter test. So 1 through 30. There's a lot of them because it's 1 through 30. Let me peek and see. Okay, so I've updated this assignment a little bit. I didn't take off that many, but I did take off a couple. That doesn't make any sense. 1 through 5 and then 6. Hold on. 1 through, so this should be 7. I'll update that. 7. But I did take off a couple of problems. So I want you to work on this. This is due for your, it says due Monday, and that's fine. I do want you to take, I need for you to consider that you're going to do it and turn it in tomorrow. Because I want you to actually do these problems. This is like the last bit of math that you need before you do trig. Okay? So if you're going to go take a trig course in college, because we didn't cover that in this precalculus course, we generally do not get to it. But we did get to most of the preliminary stuff. So I would like for you to leave here with just this last bit done. So the algebra is as strong as it can be. So that if you go into a trig class, that you're going to start fresh with that, but you're going to know everything that happens before that. So there you go. These problems have been updated. Let me know what questions you have. Obviously, we'll go over questions on Monday, and that's what I know. I don't know where. Oh, I know. Stop recording. There it is. Okay, bye guys.